Hi guys, so in the previous video, I have taught you how to use the calculator to evaluate your trigonometric ratios. In this video, I will give you a few examples on how to actually use the trigonometric ratios to evaluate unknown sides, such as here in example 1. So let's take a look at example 1. We are asked to find the value of m in this right-angled triangle, giving our answers in 4 significant figures. Alright, so the first thing you want to do when you encounter such a question is to always label the 4 things. What are the 4 things? The angle of interest, the hypotenuse, the opposite, and the adjacent. Alright, so looking at our triangle, okay, the right angle cannot be the angle of interest. So this must therefore be the angle of interest. Alright, and so the rest of the items are relatively easy to label. I know that the hypotenuse would be AB because it is the side opposite to the right angle. I know that AC would be the opposite because it's the side opposite to the angle of interest. And I know that BC therefore must be the adjacent. Alright, so taking a look at this question, we are asked to find the value of M. I know 27. I don't know anything about the adjacent. I know the angle of reference or the angle of interest. Alright, so this leads me to actually focus on the length of the opposite and the hypotenuse. Okay, so focusing on these two lengths, which trigonometric ratio do you think I should use so that I can proceed on? I have the opposite, I have the hypotenuse. So it would actually make sense for me to use the sine ratio, of course. Okay, so I put sine 36 degrees equals to opposite over hypotenuse. I want you to take some time to copy down this particular part. Okay, when you are done, please look up. Okay, so sine 36 degrees equals to O over H. I'm going to substitute O and H in. Sine 36 degrees equals to m over 27. You see that now I'm able to make progress to find the value of m. Okay, after here, it's already just simple algebraic manipulation because this is just a number I can key into my calculator. So I will get m over 27 equals to sine 36 degrees. Remember, always make the subject on the left hand side. So I will have m equals to 27 times sine 36 degrees. Just key this into your calculator and you'll get m equals to 15.8702 centimeters. Put this into 4 significant figures as required by the questions to get 15.87 centimeters. Okay? Okay, so let's take a look at example 2. In example 2, we are still given a right-angled triangle. Find the length of C, giving your answers to 3 significant figures. Okay, so same thing. Label the 4 things. The angle of interest. Hypotenuse is always opposite the right angle. Opposite is always the side opposite to the angle of interest. And the adjacent is what's left, which is 4 centimeters. So I'm asked to find C. I'm given 4. So the two, I don't know anything about the opposite. So the two lengths that I should naturally focus on is on A and H. So which trigonometric ratio do you think I should use? If you have guessed that I should use the cosine ratio, you are right. Okay, so we use the cosine ratio. Cosine 40 degrees equals to A over H. I substitute A as 4 and H as C. Does that make sense? Alright, so from here, how should I continue on? I know that cosine 40 degrees is just a value. I can just change this into a fraction. Same thing as what you always do in primary school. And from here, I can do cross multiplication to get C times cosine 40 degrees equals to 4 times 1, which gives me 4. So from here, I should be able to find the value of C simply by dividing both sides by cosine 40 degrees. So key this into your calculator and you'll get C equals to 5.2216 centimeters and C is 5.22 centimeters. Okay, so let's move on to example 3. In example 3, in triangle XYZ, you are given that XZY is 90 degrees. Given that ZXY is 35 degrees and ZY is 12 centimeters, find the length of XZ. They want me to find this length over here. Okay, so business as usual. Label the 4 things. You have the angle of interest, okay, hypotenuse, always opposite the right angle triangle, okay, the opposite is always the side opposite to the angle of interest, and the adjacent is always the remaining side. From here, if you'd like to pause the video to try this question yourself, you may do so. Alright, so let's continue. Okay, you want to find this length over here. You know nothing about h, and you are given that zy is 12 centimeters. So naturally, we should focus on these two lengths. So which trigonometric ratio should we focus on? That's right, we focus on the tangent ratio. Alright, so you put tangent 35 degrees equals to O over A, substitute it in, tangent 35 degrees equals to 12 over xz, which is what I'm trying to find. And from here, you should be able to do the algebraic manipulation. Xz times the tangent 35 degrees equals to 12. Xz equals to 12 over tangent 35 degrees. Okay, evaluate this, key this into your calculator, and you should get xz equals to 17.1 centimeters. Alright, in this last example, okay, it is not very trivial as it consists of two right-angled triangles. Okay, so as you read through the information, in a right-angled triangle ABD, BD is given as 6 meters, angle ADB is given as 30 degrees, C lies on BD such as angle ACB is 55 degrees, and they want us to calculate this length over here, length of AB. Now, we don't know any information about this length. We also don't know any information about the hypotenuse here. This is also the hypotenuse. So does it suffice for us, or is it possible for us to use Pythagoras theorem? The answer is no. So when you cannot use Pythagoras theorem, use the trigonometric ratios. And how should we do that? We have this big length over here. We have this angle over here. So it makes sense for us to focus on angle A, triangle ABD. Okay, so that's what we're going to do. So I'm trying to find the length of AB given this length over here. So same thing as usual, label the four things: the angle of interest, the hypotenuse, the opposite, which is the side opposite to the angle of interest, and the adjacent. So I know the length of AB, I can focus on O and A. And so the trigonometric ratio that I will use is the tangent ratio. So I write tangent 30 degrees equals to O over A, cos dua T O over A, which is AB over 6. Okay, simply do a manipulation, bring the 6 over, we have AB equals to 6 times tangent 30 degrees. AB equals to 3.4641 meters, okay, equals to 3.46 meters. Now don't immediately jump into your 3SF video. Always 3SF value. Why? Because you might have to use this 5SF value in the future. Okay, so label your AB as 3.4641. Let's take a look at question part B. Find the length of AC. Okay, find the length of AC. Now similarly, we do not have any information about BC, so we cannot use Pythagoras theorem. We only know this length over here, so we still cannot find AC. Okay, so it makes sense for us to focus only on the smaller triangle, and that's what we're going to do. Just ignore the 6 meters over here. So same thing, label the four things: the angle of interest, the hypotenuse. Now I'm going to use H1 because this is a different labeling as from the triangle before, and I don't want you to be confused, so you label this as H1. Okay, the opposite side, the adjacent is A1, and the opposite side is O1. Notice this is opposite the angle of interest. So same thing, okay, you are given, we know O1 and we're trying to find H1. So these are the two lengths we're trying to focus on, and the ratio we'll use is the sine ratio. So sine 55 degrees is O over H, which is 3.4641 over AC. From here, AC is just sine 3.4641 over sine 55 degrees. Do a simple algebraic manipulation on your own. Key this in your calculator and you will get AC equals to 4.2288 meters. Okay, and change into 3SF, 4.23 meters. AC will be 4.23 meters. Now you notice for this portion, I use the 5SF value. Why? This is to ensure accuracy. Okay, so I hope from these 4 examples, it is very clear for you on how to use the trigonometric ratios. Please practice using the drill and nail questions. Same for part 1 of this e-learning, use the drill and nail questions. Okay, so we will end here for today. Thank you.